Good evening to one and all. My name is Dr. Mewar, working as an assistant professor in the Department of Electrical Engineering, Mewar University, Rajasthan, Rajasthan. Today, I would like to teach about the pedagogy in the power electronics simulation part by using the software of the MATLAB. Friends, people are thinking that the power electronics subject is very hard because in the power electronics subjects, lot of circuits are there. By using that circuits, you have to, what can I say, do the numericals of V average value, V RMS value, efficiency value, these are all the things. These are not that difficult, but if you are using the shortcuts, the power electronics subject is very easy. Today, my concept is by using the MATLAB software, how can I design the mobile charger? The mobile charger is nothing but everybody you know, that one which can convert AC supply into the DC supply. Like technically I can use the term, it is called a single phase half wave uncontrolled rectifier by using the R load. Actually we have three types of switches are there. One is the uncontrolled switch, semi-controlled switch and the controlled switch. What is the difference between the uncontrolled, semi-controlled and the controlled? The uncontrolled switch means the switch on state and the off state will be depends upon the circuit condition. If I come into the semi-controlled switch, the on state will be depends upon the control terminal and the off state will be depends upon the circuit condition. The third control switch is the on state and the off state will be depends upon the control terminal only. Example, the uncontrolled switch example is a diode which have the two terminals, anode and the cathode. If you are coming to the semi-controlled switch, example SCR, semi-controlled rectifier. It has another name, it is called thyristor. It has anode terminal, cathode terminal and the gate terminal. Third one is the MOSFET, BJT, IGBT, IGC. Totally advanced power semiconductor devices are coming under the control switches. Okay. Today our topic is how we are going to designing the mobile charger. How 230 volts AC we are going to reduce it into 5 volts DC. And how our mobile charger is working. How the charger is converting AC supply into the DC supply with the different of loads. Friends, the main advantage of this video is not only the theoretical part, I am going to be explaining about the software part also. Means by using the MATLAB, I can verify whether I am giving the theoretical aspects are right or wrong. If you will follow the circuit diagram, I given the name of the circuit diagram is single phase half wave uncontrolled rectifier by using the R load. Yes, obviously I am giving the input is my AC supply and output is a DC supply. So for that purpose, I have taken suppose 230 volts AC supply as my input and I have taken the diode and I have taken my resistor. Before that, you have to remember some shortcuts and some of the important points. What are the shortcuts and what are the important points for getting the waveform? Because power electronics is totally confined to the waveforms. From the waveforms only, you have to grab the performance parameters of the each circuit. The performance parameters of each circuit will be depends upon the what is the conduction angle from which point to which point either my diode, either my SCR is going to conducting. So according to my topic, single phase half wave uncontrolled rectifier by using the R load. Uncontrolled I am using means I am going to take as a diode as my switch. Yes, each waveform I will give the different shortcuts. If you will see my circuit, input I am taking, assume in your mind, input is purely sinusoidal. There is no any harmonic content. So according to that, I have taken input is a purely sinusoidal. There is one circuit, the second circuit. Now, according to the circuit, I have to draw remaining waveforms of V0, current in the circuit. It is not a V0, it is called a VD. The VD is nothing but the voltage across a diode. And one more is the V0. Or there is a DC value, means the V0 across the resistor. If you are coming to the first waveform, input is purely sinusoidal. There is no harmonic content in the circuit. So, V input I have given the purely sinusoidal. Another case is you have to assume all the switches are ideal. You know, the meaning of the ideal is whatever the V input equal to V output. Means whatever the value when the switch is going to be on. Suppose ideal, whatever the V input equal to V output. Already I told uncontrolled switch is nothing but on state and off state of the switch depends upon the circuit condition. Means if you are going to giving positive supply, my diode is going to be on state, forward bias. If you are going to giving the negative supply, my diode is going to be the reverse bias. It is nothing but the off. If I want to draw the waveform of V0, I will apply this concept because my switch is ideal when if you are going to give positive voltage across the diode, my diode is going to be on. If my diode is going to be on means what is the V input equal to V output? Means what is the value of input value equal to that the value of the output. Example, from 0 to pi, I am going to giving this positive applied voltage across my diode. My diode is going to be forward bias. When it is in forward bias, V input equal to V output according to the ideal switch. So from 0 to pi, my diode is going to be forward bias. So whatever the V input value equal to V output. Now, if you are coming to the negative half cycle, if you are going to give it negative voltage across the diode, it is going to be half state. Obviously, from this point to this point, the value is going to be 0. For another cycle, same concept I am going to apply when you are going to giving the positive voltage across the diode, V input equal to V output. Again, the cycle will be repeat. It is a vice versa. Friends, it is not a very difficult. It is very easy. Just I am using the concept of the ideality. Now, if I want to draw the waveform of the current in the circuit, there is no need to go to any what can I say KVL and KCL, these are the things. You just apply our Ohm's law, V equal to IR by using the resistive load. What is the I value equal to V value? So what is the value of the I equal to V? So the waveform will become like this. Otherwise, you can see when the diode is forwarding bias, the flow of the current will be there. The diode is going to be reverse bias. There is no value of the current, that is a 0. So it is a 0. There is no any problem. So again 0, pi, 2 pi, 3 pi. Again 0, pi, 2 pi, 3 pi. If you are going for the voltage across the diode, one important point you have to remember, because this point is very useful in the gate exams also. If the switch will be on state, means the diode, whatever it is, power semiconductor device switch, if the switch will be on state or forward bias, it cannot block any voltage. If you will see the waveform here, from this point to this point, my diode is in forward bias. According to our shortcut, according to our concept, if the diode is in forward bias, it cannot block any voltage. So, in forward bias, voltage across the diode from 0 to pi, the value is 0. And one more thing is, if my switch will be in reverse bias, otherwise if my switch will be in off state, it can block whatever the applied voltage. So, from the value of the pi to 2 pi, my switch is in the reverse bias. In reverse bias, it can block whatever the applied voltage. So from pi to 2 pi, my switch will be in the reverse bias. It can block whatever my applied voltage. My applied voltage across my diode is or switch is negative voltage. So it can block my negative voltage. So again 0. Again it can block. So hence proof, diode can block only negative voltage only. So from this circuit, we understand that by using the 2, 3, 4 shortcuts, means all the switches are ideal, and the concept of the blocking voltages, we found that it is a waveform of the single phase half wave uncontrolled rectifier. If you want to do practical, take the breadboard, put the AC supply 230 volts, you take it from the supply, put the diode, take the resistor, you can get the same CRO, you can measure the output voltage also. So, if I am giving 230 volts AC, might be, sir, where is the DC here? You can ask, I am DC and AC is also not a pure AC. That is the concept of the harmonics. We will discuss the later. Let's assume by using this circuit, I reduce the means conversion of AC supply into the DC supply by using the concept of single phase half wave control rectifier by using the R load. Here, my conduction angle of my diode is 0 to pi. By using this conduction angle, because each load the conduction angle is going to be changed. By using R load, my conduction angle is 0 to pi. Might be RL load, might be it can be changed 0 to pi plus sigma. But RL load or another RL load is going to be changed. So, according to today's concept, my conduction angle is 0 to 2 pi. So, by using these conduction angles, you can find different performance parameters. V naught average value, V RMS value, form factor, ripple factor, efficiency. These all things will come sequence depends upon your conduction angle. Especially for the who is preparing for the gate exam, these zero conduction angles are very important. If the waveform is wrong, means conduction angle is going to be wrong. If conduction angle is going to be wrong, means your total performance parameters are going to be wrong. So friends, you try to concentrate on not by hearting the waveforms, by using the logics for the waveforms. If you know the logic, you know the conduction angle. If you know conduction angle, you can find V average, V RMS, these are the things. So, theoretical part has been over. Now, check out for the MATLAB software. I will try to hence prove my concept is right, both theoretical part and MATLAB software part. Then, our first concept has been over. Thank you. Keep watching my videos and please subscribe. So, if you are coming to the our second part, now theoretical has been over. In Blackboard, I have been shown how we can design the 5 volts battery charger, means how it can convert AC into DC. If you are seeing, it is very small concept. It is nothing but the technically single phase half wave uncontrolled rectifier by using the resistive load. If the loads you are going to keep on changing, the conduction angle period of the switch is going to be changing and the waveforms also going to be changing. So now I have to prove whether my concept is clear or not. For making myself proof and making you understand, now I am going to using the one of the important tool of electrical engineering departments where faculties are, not only faculties, students also using MATLAB. Whatever the theoretical part what we have been discussed, whether it is right or wrong, otherwise lot of nowadays electrical vehicle projects, whatever the renewable energy projects, everything people are using the MATLAB software only. It is a very, what can I say, cooperative software. So today I will give just only basics part of the simulation of the MATLAB. If you will see, in front of you one window is there, just I have double clicked the MATLAB icon on my desktop. Now this window has been outside, then you just click the button of the Simlink. Simlink is nothing but a library. In that library you can wrap out lot of the elements. It's not like a center library. If you are going to the center library, lot of the components you will, in textbooks you will get. Like that, if you are going to the Simlink library, all the components related to the power electronics is available. So whatever the backside you are seeing, circuit diagram have been drawn, same thing I will be draw here also. So whether we have to check our whether waveforms is right or wrong. So before going to opening, I will give small what can I say shortcuts to you. Nothing else. Input is purely sinusoidal. So I have been drawn the input is purely sinusoidal. I am not considering any harmonic content. There is only harmonics. I am considering everything is the ideal. So switches is also ideal only. So the switch will be on. Whatever the input equal to output. And one more thing is what can I say? Blocking voltage. The blocking voltage is nothing but the voltage across the diode. Means when the switch will be on, switch cannot block any voltage. If the switch will be off, it can block whatever the applied voltage. If you are seeing here in our screen, I think the Simlink library browser we can. In this browser, we can accumulate lot of the components which we require for your circuit diagram. And in that Simlink library browser, you go for the new file. In the new file, so here one new file came. In this new file, you can you can save this new file for future purpose. If your system is going to hang over anything, you can reopen this file. So I can save with the name of what can I say? I can save on the desktop only, no problem. I can put here mobile charger. Why you are using mobile charger? In our mobile charger, it is a circuit only. 230 volts AC supply into 5 volts AC supply. Whatever laptop charger also This depends upon the application, depends upon the ratings. Might be it is still not valid, so I can save it another. Otherwise, I will put MATLAB 1. I will put just not save the file. Just again, I can try to save HWR. Save it. Yes, it has been seen after rectifier. Just whatever the components you can take from the library. First in my circuit I have 230 volts AC supply. So if you are going to the Simlink library browser, you can go here, you go for the SimPower systems. The SimPower system is a subsystem. In that subsystem all the components are available there. So it's taking a little bit time. So I got electrical sources. So electrical sources have taken AC voltage source. And more things I have to know elements. So going to the element blocks, you can find your loads. Like I will take a series RLC branch. And yes, for electronic subjects we are teaching means I can take what can I say? I can use as a diode. So diode I have been taken. So I have to find voltages and currents in the circuit. So practically we are using the CRO for finding these all the results. In MATLAB you can go for the measurements. In measurements you can go for the we have been taken. So voltage measurement I have taken, current measurement I have taken. Now I will connect some power sequences. You just AC voltage, diode, and how to measure current in the circuit. I will maximize my screen. So now you easily can understand what I am telling to you. The AC voltage I have counted here. I will do very fast, please don't mind, because the video is taking only each 5 minutes interruption is coming. Now just you take here, I want load is only R load only. So I will put R only and I will put OK. Then I will look at this one, I will put R, then I will connect it here and I will do to close my circuit. Then so here one more voltage measurement I can take, copy, because I have to measure voltage across my resistor also, paste it, and it is my voltage across supply, and one more voltage measurement I will take, I will paste here. This is a voltage measurement across. So it is my voltage across load. So for showing output I would like to go to library. Just I will go to the library, I will go to the things. In things one device is available scope. I will drag here. Total how many outputs I have? 1, 2, 3, 4 outputs I have. So I will try to enlarge my scope according to my convenient. Double click I will put on scope. And I will go to the axis and I will give number of axis is a 4. Then I will put it is a OK. So now one by one you can connect according to your blackboard circuit diagram. It is a positive here, the negative here, and the first output is I will go to connected here. Whether I will check whether my concept is right or wrong. Second one is the V0. V0 also I have been connected here. So if radical is coming means your simulation is connection is wrong. Now again I will take here and I will connect it here. So I want to measure current in the circuit. So current in the circuit V0 and I both are same only. Why I am telling I am using the small shortcut of the Ohm's law. The V equal to IR. So it's only for the resistive load only, not for all the loads. So whatever the V0 waveform is same as the I waveform. So there is no any bother about it. I would like to find voltage across the board. Then I save the system. Then as soon as possible you try to give the performance parameters. My performance parameters I have given 230 volts AC. And I would like to give my frequency 50 Hz. I will put it as a OK. Then I will give my resistor value is, suppose I will put 5 ohms. Okay, no problem. Now let me check simulation. configuration parameters I will go. And what can I do again? In configuration parameters are very important. Just to give stop time, I will give 0.04 and I will give ODE 1560 MDF. Then I will put okay. Then I can save again. Just I will see AC voltage frequency 50, no problem at all. Now you just save the system and you run, and you will see if my concept is right or wrong. So I'm also getting tension. Just you could double click here. Yes, you go to the zoom. What happened? Something wrong came. It should be voltage measurement. Positive I have given, negative I have given here. Yes, negative I have not given properly. Here I have given negative. So I will connect here. I save here and I run here. Now I will plot my waveform. Yes, obviously 100% I am right. It is purely sinusoidal. V0 I diode block negative voltage. So it is the thing. If you like, please subscribe to my videos. And I am Dr. Shiva, belongs to Mewar University. Electrical department admissions has been open. So if you contact number 756896314 is my contact number. So regarding any admission in faculty of engineering department or any department, you can approach us. Thank you very much.